So we'll do exactly as last time. There will be 30 minutes lectures. There will be 30 minutes break, which includes you should discuss some topics and we will have a little follow-up on that. And then there will be a second 30 minutes lecture. Okay, I will start by share screen now. Share. Kan man inte stänga den då? Så. Okay. So I hope it's okay now. You see it clearly? Okay, I will start by referring to, also, can I get rid of this one? Yes. So, referring to an American historian, John McNeill. He started in the 1990s with the idea of writing a book on environmental history, thinking that these environmentalists there are exaggerating very much as always. And his title for the book he planned was Nothing New Under the Sun. But when he started to look at data, he changed the whole topic and said, much has happened to the environment during this 100 years he was looking at, the 20th century. So the book has the title Something New Under the Sun. And this is, I just tried to make one table out of this several hundred pages book. You see here what you found. Oh. What's happening now? The global population increased 4 times during this 100 years, from 1.5 to 6 billion people. The global economy increased 14 times. The industrial production increased 40 times. Energy use increased 16 times. And together with that, very much carbon dioxide emissions, 17, and sulfur dioxide emissions, 13 times. Ocean fishing.
Hello, excuse me, Mr. Lars, can you give us an extra 5 minutes because we have some problems with our microphone. We can't hear you easily.
You can't hear me, okay?
Yes, just a 5 minutes.
I hear you very well. Should I start from the beginning? Do you hear me now?
Yes, but it's very low, very low.
Very low. I don't know. I did just as last time. Is there
some problems with our
turn microphone. Well, I'm not sure I can do so much more. I can talk a little louder, of course. Hello? Do you hear me now? Students? Please answer, students.
Can you speak something?
Yes, I'm talking now fairly loud. I'm shouting, in fact.
It's too low.
So do you hear me now? Is it any better?
Yes, you can continue your lesson.
Well, I start from the beginning.
Okay.
Okay, I'll go back. Okay, I start from the beginning. So we will start by looking at the American historian John McNeill. He had the plan to write a book on environmental history for the 20th century. And with the idea that the environmentalists are exaggerating, of course. There is nothing new about the environment during these 100 years. But when he went through all the data, he changed his mind dramatically. And his book has the title, Something New Under the Sun. And his ambition is to describe the global environmental development during 100 years, 1900 to 2000. And it's a several hundred pages thick book, but I extracted some basic information. So what happened during these 100 years? The global population increased 4 times, from 1.5 to 6 billion people. The global economy increased 14 times, industrial production 40 times. Energy use 16 times, similar to the economy. Carbon dioxide emission, of course, similar as energy. And sulfur dioxide emissions, also similar to energy. Ocean fishing increased 35 times, like in industry. Number of pigs increased 9 times. Note that it is twice as much as the population, meaning that on average, people eat twice as much meat. Forests decreased 20%, and instead fields for agriculture were doubled. On the other hand, for example, the blue whale, only 0.25% were left after these 100 years. Now, of course, perhaps I should mention that some of these things changed a little. So, for example, the blue whale is back in a fairly good condition. But all the others increase still. Meat eating, deforestation, carbon dioxide emissions, etc., etc. You can also look at several of these developments. Here I've shown some of them. And the important thing to mention here is that they are increasing with the almost constant percentage-wise increase from year to year. And of course, this is the same as exponential growth. So some of these increase of resource use is exponential, meaning that the second derivative versus time is constant. Yes, and you can see it on fertilizer, loss of rainforest, paper consumption, number of cars, etc., etc. You can look at very many things. Most of this development happened, or the most dramatic increase happened somewhere between 1955 to 1975, you can say. One generation was very much responsible for the increased resource use. I will talk about two types of resources, the non-renewable and the renewable, and we start with some comments on the non-renewable resources. These resources are slowly emptied, but the environmental consequences of the end product accumulation will often appear long before the resource is emptied. There are many examples, and of course, the most clear example is fossil fuels. So this is now extraction of fossil fuels, lignite, or brown coal if you wish, from a mine in Germany. And this is just one example of the enormous scale of extraction of, coal, lignite, black coal, lignite, oil, gas, and so on. And it's being used for energy production. This is, for example, Bełchatów in Poland. It is the largest electricity producer in the country. You see the lignite field close to it in front of the picture of the factory. And it's also used very much for transport. So this is now a motorway in the area of Los Angeles. You see it's enormous amounts of cars. So these are two main consumers of fossil fuels. You see the use and extraction of fossil fuels is increasing. This is data up to 2019. Oil is still increasing. Coal is starting to level off. The gas is increasing a little, while the others up there on the right-hand upper corner is really not very much. Yeah, and we thought there will be a peak oil and then the oil will simply not be possible to extract any longer. So we will have the end of the oil age, as the economist told us, and many research projects, by the way. But it doesn't look like quite. This is the most recent data. And you see there was in the 70s, there was the oil crisis. We thought it might be the peak oil. And then in 2005, we thought there might be the peak oil, and there was a leveling off, in fact. But then you start to extract shale oil and oil tar sand and so on. So it increased. And they also somehow include non-conventional oil, like oil from the ocean bottom and Arctic, etc. So it's still going on, although there is an agreement that it should level off. So it doesn't look like much of an end of extraction of fossils. Okay, the next non-renewable resource I will comment on are the metals. This is a picture of the largest iron mine in the world. It's Kiruna in northern Sweden. Now with iron, it's not much of a problem because there is much of it. There is much left in northern Sweden, for example, and on other places as well. And it's not toxic. Its accumulation somewhere is not so serious. But of course, there are other metals that's more of a problem. For example, the so-called rare earth metals, the REMs. And here is just a reminder that many of these metals are being used in modern technology. For example, in hybrid electric motors, generators, wind turbines, and so on. Here are some of them. You see 7 of them are listed here. And of course, they are rare, meaning that's not so much of them. Much of it is being exported from China. So China becomes very dependent. We become very dependent on China for access to these rare earth metals. But some extraction of them people start to look at it in other parts of the world, including our country, that is Sweden. And the question is what to do with the metals to improve the situation. And here is fairly straightforward. We need to recycle metals. So metals that have been used have to be brought back to the new uses. This is much of a reality today. Steel, for example, is today produced from more scrap iron than virgin metal, but it's there. Sorry about that. Copper is much recycled because recycled copper is cheaper than virgin copper, so it's a very good market. Lead, of course, is a toxic heavy metal. So it is, at least in our country, in Sweden, it is by law recycled, and it's fairly efficient. As far as one can see, more than 99% of lead in, say, car batteries and so on, is recycled. Mercury is too toxic, and all uses of mercury is being illegal now. The mercury is taken out of the resource flow and stored in mines. Recycling of rare earth methods has to be improved very much. That is, I think everyone agree on that. Okay, so much for the non-renewable resources. We will talk a little about the renewable resources. And also these can be managed in not so good ways. They can be harvested faster than they are reproduced, and then they can also be, emptied. Very clear example comes from fisheries. As you noted from John McNeil's tables, fishing in the Atlantic is increasing extremely much. And you see on this map of the world when there was the peak fish in red color. You see year down to the left, you see the year, it's 1960. Now it's 1970, and the red areas have been now overfished. Peak fish was passed. I'll do it once more so you have a chance to look at it while it's. So the global peak fish, I think, was in 1996. And since then, fishing from the oceans has decreased. And quite many species are being threatened simply by extinction. Most fish we eat today, it comes from aquaculture. This is a special example. It's the cod fishing on the east coast of Newfoundland. It's a classical, enormous area for cod fishing. The immigrants who came there in the 19th century and also early 20th century, they could simply lower something down into the water and take it up and have cods in it. There was so much cod and also big codfish. And of course, the fishing boats were developed and they were more or less industrialized. They have eco possibilities to locate the fish. They have big trawls and so on. So they were, pushing the Canadian government to be allowed to fish more. And the government tried to regulate the fish, but at some point they gave up and said, okay, fish as much as you wish. And this was after a few years, in 1992, there was no more cod. Of course, they have very good economy after that point, but at that point, 1992, all the fishing vessels went out of business, and about 20,000 people on the mainland also lost their jobs because there was no more fish. Of course, you recognize this from the Aral Sea, so you know what I'm talking about. There is still not good cod fishing outside Newfoundland, and now 2020 is more or less 30 years ago. So it's just the tragic of the common being illustrated. Okay, there are other non-renewable, renewable resources which are misused. For example, forests. We know that wood, timber, and paper, for example, come from the forests, and they are being overexploited. Also, topsoil is as a new renewable resource that is being emptied much quicker than it's being regenerated because of industrial agriculture. Too much of the soil is being, too deep layers of the soil are being plowed and so on, which makes the organic amount in the top part of the ground to be oxidized and disappear to the atmosphere as carbon dioxide. So topsoil is today destroyed much faster than it's being generated because it's generated naturally, and agriculture can be done in such a way that topsoil is not destroyed. But it's not the case. And of course, water. We will come back to water. Water is overused, but it's also regenerated. So it can be taken care of more carefully. We'll come back to that later. Okay, I'll come back to the study of the limits of global resources. We know the limits to growth from 1972. I mentioned last time. It was updated in 2003. We'll come back to that. There is also a very important study on the ecological footprint network. There is the material flows studies of the Wuppertal Institute. There is the research project in Chalmers, and there are the Planetary Boundaries in Stockholm. I'll come back to all these things. Firstly, the 30-year update of limits to growth. It was published in 2003. And you remember perhaps peak and collapse. It's being said we are witnessing a terrible validation. The original Club of Rome report, that is limits to growth, alerted the world to the dangers of continued exponential growth against natural limits in a finite system. The finite system is our planet. It is noted that humanity had the capacity to create systems that were sustainable. However, this did not happen. On the contrary, the limits to growth was attacked very much by the economists, but it is validated by over 30 years of data, and now it's over 40 years of data. So we see there are limits to growth. These are some of the scenarios that were calculated in the 2003 report. It's based on the model, system dynamics model called World 3. And you see the parameters up on the top picture here. You see the resources like that, the population like that, food is going on there and so on. I try to get rid of this thing here. Well, I can't. Well, industrial output is peaking there and so on. There's also, these were resource flows and so on. Here we have material standard of living. So food per person, service per person, life expectancy, and so on. And then human welfare in the lowest part here. There's indexes for that, for example, the UNDP index, and of course the footprint. We'll come back to that. You notice that the peak in these more careful calculations is about 2025. So it's only a few years ago, in a few years into the future. But of course, this is based on business as usual, meaning that the development is not changed by better resource use and so on. It underlines very much that we have to improve our way to handle resources. And resources management can be improved. I give you some examples. Well, we are very much used to this picture since many years. Resources are being extracted. They are used in the production of things. The things are consumed, and then they are turned into waste. It's a linear resource flow. This has to change into a cyclic resource flow. Resource production, consumption, waste, and the waste goes back because it is a resource. You have these rules then: reduce, reuse, recycle. That's how it should be. You should reduce your resource use. The material goods that you have should be reused, they should be repaired and so on. If you have whatever trivial case if you have a car and it's, and you don't need it any longer, you should give it to somewhere else who should use it. Or you have something for your children and the children are growing up, whatever toys or bikes or whatever they have should be given to a new child. And recycle means that the components of the various things you have should be reused to build new products. Reduce, reuse, recycle. And sometimes you can't recycle. Then you might recover it in other forms. For example, something of organic waste can be used to produce heat or electricity. Of course, these 4 R's could be, developed quite much, how to deal with waste. So for a good resource management, we need perfect recycling. The resource goes to production, goes to use, goes to end of life of the product, and go back to the resource. This is what we call cradle to cradle, C2C. The cradle to cradle has been developed quite much by Braungat in Germany and McDonough in San Francisco in California. And they have a cradle to cradle book that is some years back now. And they have 2 new books, by the way, which I don't show. It's called Downcycling and Upcycling, how to upcycle things, And companies can be certified according to cradle. So they show how all the products they produce and sell are able to be reused or recycled. So you can have a certification from C2C, and hundreds of companies have that. Well, that was the first part of this lecture. So now there is a break, and of course the break starts a little later than it should be, about 1.5 hours later. So use this break to discuss how do you yourself improve resource use? How do you apply the 3 R's? How do you manage waste? What do you do with your waste? And then we'll be back in 20 minutes and you tell me what you have concluded. Now here we are. So it's now the second half. We look a little more at quantitative measures on the resource flow. And the first one is to introduce the concept of the ecological rucksack. Rucksack is what you carry on the back when you are traveling, for example. And the background is that about 5% on average of the material resources taken from nature end up in products. The rest becomes waste. For example, some 30 tons of nature is used to create 1 ton of car, not counting the water, which is rather important also for car. And for many industrial goods, the ratio is similar, that is about 5% ends up in the product. And note that it's a similar thing with using internet or ICT in general. The cost for a message on internet is not zero at all. It's important, and because of all the servers and so on. So sending one email is about the same as producing a couple of aluminum cans for beer. These things can be very well studied by using life cycle assessments, LCA. So the life cycle assessment is a measure of material intensities. And the material intensities for all different products can be found on tables available on the internet. And of course, there you can also estimate the rucksack. And there is also interesting measure called MIPS, the material input per unit of service, MIPS. For example, if you travel from point A to point B, what is the MIPS? Of course, the MIPS is very large if you travel by an airplane, and it's almost nothing if you walk. And the question is, what is it? You can compare different ways to produce a service. The most commonly used way to estimate quantitatively a product or a service is called ecological footprints. The footprint concept was introduced by William Rees, a Swiss person, in 1992. And the footprint is the surface area of the population needs to continually satisfy its needs and produce its products and services. This is measured in the so-called global hectares. At the time, there was, in 1992, there was about 1.8 global hectares per person, per capita, on the planet. Today, this has gone down because of population increase and also destruction of the area itself. So it's closer to 1.6, in fact. Ecological footprints is of wide use in society. It's used by the general public, by companies, by authorities, and so on. And note, it's a quantitative information, and it's not environmental labeling, it's just a measure. And you can find information with this link I provide here. The footprint used to be divided into 6 different parts: forest products, carbon footprint, cropland, pasture, built up land, that is cities and so on, and fisheries. So they all have a share in the footprint of a person or a society or in the planet for that matter. Once more, you have the food, fiber, and timber footprint. You have the energy footprint, and you have the biocapacity footprint. And all this can be calculated. There are methods for it. For example, the use of fossil fuels correspond to a certain amount of the carbon dioxide produced corresponds to a certain amount of land area that could produce that amount of carbon dioxide. Nuclear is a similar way it can be done, in fact, and hydropower can also be taken care of calculation-wise. So it's very worked through way to calculate your environmental impact. Here is a graph of the development of the footprint on the planet from 1960 up to 2008 in this diagram. You see the world biocapacity, the 1.8 around in 1970 or so, 1990 or so. It's called 1 here. And you see around 1970, we started to overuse resources. We use more resources on the planet than what the planet can provide. So this is a very important year. It's after the period I mentioned, 1955 to 75, more or less, when the resource use increased very much. And you see still going on this increase, although not quite as quickly. You see the different ways here, especially carbon footprint, that is energy, is increasing very rapidly. These are the figures up to more or less today, it's 2017. And you see still the carbon footprint is very big. Here it is divided a little in various ways. So you see the high income countries, industrialized countries, the rich Western countries, if you wish, have a very large footprint, 4 or 5 rather global hectares per capita. The middle income countries is much lower, and of course the low income countries is well below what the planet can provide in terms of global hectares per capita. And you also see the biocapacity going down. The biocapacity, that is what the planet can provide. So this is, I'm sorry to give you a number of very negative information all the time, but that's the situation we live in. You know, this fact that the global footprint is larger than what the planet can provide has led to the concept of Earth Overshoot Day. That is the day on the year when we have used up the resources that the planet could provide that particular year. And the Earth Overshoot Day, you know, it started to pass January 1st in 1970 or so. And last year it was August 22 for the entire planet. But of course, countries use different amounts of resources. In Sweden, we use more than average. So the Overshoot Day was already in April. And in Uzbekistan, you use less than the global average. So it was in October 20. So this global ecological overshoot, it depends on how much we consume, how efficiently the products are made and used, how many people are there living on our planet, and how much nature's ecosystems are able to produce. So here you see that the global biocapacity has been shrinking to 1.6 gigahectares per capita now. It is, you know, the use of resources increasing still, and the biocapacity is decreasing. So if this continues like that, in 2030, it will be December 31st. That means that we will be using twice as much as the Earth provides. we would like to change that development so it's less. The day for overshoot comes earlier and earlier and earlier. The overshoot is a very practical measure, and you can calculate your own. You can calculate that of your country, and you can calculate that of the whole planet, of course. And there are some such footprint calculators that you can use for your own person. I just give you 3 links here, which you can go to and you find such a calculator. And some of these are very crude, you can say, and they rely on statistical data that is collected from some countries or some country. So don't believe too much in them when you are in a different situation. That was the background for the calculation. But anyhow, you can see how it's being done. So please try that. Now, it's very important to mention what can we improve? What can we do to improve things? Well, it has much to do with resource efficiency. And I just give you some examples. There are very, very many. For example, this is Gunther Pauli. Gunther Pauli, he's South American. He has created what's called ZERI Foundation. ZERI meaning zero emission resource invention. He is extremely inventive, and he has produced this particular book called The Blue Economy, where he has a number of innovations that could be used and how to create jobs using these innovations. It's very much based on how to produce things from nature. So it's rather agricultural, but it's a very interesting book. Another book is this Factor 5. It was produced by Wuppertal Institute in Germany. Ernst von Weizsäcker, main author, but you see a few others of them, and you see also the link there. They are basing their idea of Factor 5 on technology and innovation increase. And they look at these waves of innovation that we are into now. You see the first wave was in the 18th century even, water power, mechanization, and so on. Next wave was steam power. Next wave again was electricity, chemicals. Next wave again was petrochemicals, electronics, and so on. Next wave again was digital networks, biotechnology. And the wave we are having right now has to do with sustainability, radical improved resource productivity, systems design, and so on. Green chemistry, industrial ecology, renewable energy, and so on, nanotechnology. That's our present wave of innovation. And in the book Factor 5, they explain how you could produce, for example, a train with 5 times less resources than what is common today, or how to produce a car with 5 times less resources, or how to produce food with 5 times less resources. So it's quite interesting book, in fact. A little technical, it's for engineers. And of course, the production itself is a very, very important part of this. And it may be improved tremendously by using cleaner production, CP. Cleaner production is good, not only for the environment, but also for the economy. You make products efficiently with less resources, not pollutants inefficiently. And we'll come back to cleaner production in this course. So remember cleaner production. Now, I would like to mention planetary boundaries. It's very important when discussing resource flows. Planetary boundaries was a concept that was developed in a huge international project that was coordinated in Stockholm by Johan Rockström, is famous now head of the Berlin Climate Institute. They are looking at what is a safe operating space for humanity. They are identifying and quantifying planetary boundaries that we may not go beyond, and environmental change that we may not go beyond. So you see here, they see that we are going well into a situation where human impact is so important for the planet that we are talking about Anthropocene, the geological era when human society is the most important factor for the development of our planet. And these consequences of the global environmental change are all connected and, of course, important for sustainability. We can see here they are looked at 9 different parameters: climate, ozone, aerosol loading, ocean acidification, fresh water use, it's important for you perhaps, chemical pollution, agricultural land use, biodiversity loss, and biochemical loading. And they have all been quantified. There are indices how to estimate them and so on. And this is what it looks like today. You see the outer line here on these 9 edges are, well, this is what you can see. And the green area is what is sustainable, and the red area is what is not sustainable. So you see the most dramatic overload or beyond sustainability is biodiversity. So the loss of species is now extremely rapid, perhaps 100 to 1,000 times more rapid than it would be in a situation without human society, according to estimates. So that's serious. We need more protected spaces. In fact, humans is now a very large part of animal biomass. Humans, together with all the animals that the humans are using, so to speak, like cows and pigs and so on, it's about 96% of animal biomass. So it's very, very large part of it. Of course, you see other areas which are very badly transgressed is climate change and biochemistry cycle, the nitrogen and the phosphorus.
Okay.
What has been a success is the change of stratospheric ozone depletion. The ozone situation is improving.
Okay.
Now we live in the Anthropocene. That's a fact. It's a sad fact, perhaps. But then, what about humans? If we just talk about these planetary boundaries, if we go within the planetary boundaries, are there still a place for us people? Well, that was the question asked by the British economist Kate Raworth. So she invented this donut economics. You know, donuts is a cake, if you wish, from developed in I know it only from United States. I don't know if you have it perhaps in Uzbekistan. Anyhow, the donut is something that is empty in the middle. That's where we have the social foundation, for people. They have gender equality, housing, health, education, income, worth, peace, justice, and so on. You recognize it from the Sustainable Development Goals, perhaps. and on the outside you have the ecological ceiling, as he calls it. It is the planetary boundaries. So this donut is the safe and just space for humanity. That's what we need to create.
Yes.
In a regenerative and distributive economy that's within the planetary boundaries and taking care of the social foundation. So
Okay.
that will be the end of today's lecture. I just remind you that you have some reading to do.
Okay.
And that's the end of today. So thank you very much for listening. I hope it was possible to understand everything.